In this presentation, I'm going to clone an ECU out of a vintage Mercedes E320. This ECU is probably not supported by many of the tools available today, primarily because of its age. Okay, and we're going to do it using Automotive Kit 2, which includes the ACOM adapter, and we're going to need the ACOM 2 adapter because this ECU does not have an EEPROM in it. There is no 8-pin EEPROM to which we will connect. This ECU holds its data, its vehicle-specific data, in EEPROM memory, but the EEPROM memory is actually in a Motorola microcontroller. Okay, and in order to access that memory, we have to basically use the ACOM 2 adapter, and the ACOM 2 adapter is called ACOM. A stands for asynchronous, and COM stands for communication. And not all modules are actually the number of modules that use the Motorola microcontrollers. There were quite a few. They aren't probably as frequently used today, because other companies mastered the ability to incorporate the EEPROM onto the silicon of the microcontroller. But Motorola, they were the first company to be able to do it. So they got a lot of design wins, and because of that, they were used in many different vehicle manufacturers' modules. Toyota uses it in their one of their ECUs for the Camry. Ford used them in the one of their digital clusters. BMW used them in their EWS modules. And Mercedes used one of them in this particular ECU. So I've already taken these apart, and I'm not going to spend a lot of time going over how to take out screws and things like that. But I will show you where the Motorola microcontroller is, and then I'll show you how we're going to connect to it, and then we'll go ahead and perform the process of cloning from the original source, which is defective, into a target, which is from a salvage vehicle. So let me open this up, and you can see, okay, like I said, I've already taken out the screws, and this comes apart. It's actually two separate assemblies, and if you can see it here, there's a whole bunch of, you would think that this would have some 8-pin parts, have an 8-pin EEPROM in it, but it doesn't. The Motorola processor is right here. I normally have my pencil. There's my pencil over here. In this processor, the different families of Motorola processors that communicated asynchronously, and as I said, that's what the ACOM 2 does. It allows you to talk to those. They come in different package sizes. This is a very common package size. This is a 52-pin PLCC. PLCC is plastic leaded chip carrier. And I'm going to zoom in so you can get a better look at the processor. Okay, here we are zoomed in, and one way to tell that it's a Motorola processor is it's got an M with a circle around it right here. Okay, and that M stands for Motorola. As I said, this is a 52-pin PLCC package. It's got 13 pins on a side, and I'll show you how to identify pin 1. Pin 1 has a dimple, and the dimple is right here. You can see it. There's a dimple in the package. And the way that the pins are numbered, the dimple is pin 1, and then it goes around to the left, down, across, back up on the right to pin 52, which is just one pin to the right of pin number 1. Okay, so that's how you determine which pins are which. And the reason we need to know that is because we're not going to do this out of circuit. Okay, we're going to do this in circuit, and we do these parts by connecting probes to the pins to the appropriate pins of the processor to which we need to communicate. So I'm not going to belabor the pin or the probe attachment process. I'm just going to do it, pause, attach them, and then we'll proceed from there. But before I do that, I'm going to show you how we know where to connect the pins. Okay. With all of our kits, we provide a documentation, and the documentation will show you how to connect to parts. And the documentation is available on our website under down at the bottom of the home page under documentation. That brings up a page, and you can find the appropriate document that you're looking for. There's lots of stuff there. But anyway, that's where that is. Now I'm going to switch over. I've already downloaded this, and I've already got it on the computer screen. So let me switch over to that, and that way you can see how I know where I'm going to hook my probes. Okay, this is the diagram for that particular part. Okay, this is a 68HC11E9, and I'll show you how we know that in a moment. Okay, but if you look, you can see that we have the probes are colored brown through gray, which brown is 1, red is 2. They follow the EIA standard color code up through gray, which is 8. But the colors in this case don't match the pin numbers. Okay, so you have to look at the diagram, and then you connect, for example, over the red probe to pin 1, the blue probe to pin 2, the violet probe to pin 3, the yellow probe to pin 4, the green probe to pin 17, the orange probe to pin 20, the brown probe to pin 21, and the gray probe to pin 26. All right. These three are all ground, okay, which or the negative power supply. Pin 26 is the positive power supply, and then the other connections are the connections which are necessary to establish communication. Okay, so that's how we know where to connect the pins or the probes. Now, how do we know what the part is? Okay, because if you look at the part itself and the information which is printed on it, you'll see a whole bunch of numbers at the top. But look at the fourth line. Okay, the fourth line says 4E28B. All right, well that's what's called a mask number. And you can tell a mask number by the fact that it's always going to have an alpha character, in this case E, followed by 2 numerics, in this case 28, and another alpha, in this case B. The 4, a lot of people talk about, you know, the mask number is 5 digits, which it is. But the actual way that the part to which you're going to connect is you have to relate the mask number to an industry standard part number, because the mask number is what's meant by mask. It's the photo mask that was used to fabricate the part. Okay, and this part has a program in it written by Mercedes, or whoever Mercedes contracted with to design this module. And the mask number, basically when they fabricate this part, the program is built in or programmed in. This is not a erasable and changeable part. Okay, this is not a flash memory based part. This part is ROM, read-only memory, and the program goes in it when it's made. Okay, you can't change it. But the double EEPROM area of this part is where vehicle-specific data is stored. You know, anything, the VIN, key information, anything like that that would happen to be relevant to the vehicle is stored in the EEPROM. That's programmed after the module is fabricated. As the car rolls off the assembly line, they'll program that's the last thing that the vehicle gets programmed with, and that's true of any car. All right. The other thing that I want to show you is let's see, where's my pencil? Just as another bit of information, right here, this is the crystal. Okay, the silver can right here is the crystal. All right, that establishes the operating frequency of the processor. When we communicate with a processor, we provide our own frequency, so we're going to override that crystal. But we don't have to take it off or anything or short it. It's just going to get overridden. So that's the part. Now let's talk about how to find out what the industry standard part number is. Okay, remember the mask in this case is E28B, E28B. Okay, so what we're going to do, I'm going to pause this and I'm going to start our software, and then I'm going to show you how to figure out what the actual physical part is based on the mask number. Okay, I'm going to go ahead and start our software. I'm going to basically start it from the beginning so you can see what I'm about to do. The next thing, this is the device selection table. I know we've seen it in our other videos, but I wanted to show you the EEPROMs or the Motorola microcontrollers are toward the very end. These are all parts that we support. These are the serial EEPROMs, and then we're going to go all the way down here. Okay, if you look right here, Motorola 6805, 08, and 11 series microcontroller. These are all the industry standard part numbers. They're not mask numbers. Okay, so I don't know which one of these the mask number represents, right? So we have E28B, but it's going to be one of these part numbers. So how do we find out? Well, what I'm going to do, I'm just going to enter an 8-pin EEPROM to get me past the device selection table. Then I'm going to show you how our librarian allows you to determine the actual industry standard part, which that's what these are. These are the industry standard parts for the different Motorola microcontrollers that we support. Okay, so I'm just going to go ahead and enter 93C56, which is my favorite EEPROM. And that's how you would set it up for the 93C56, but we're not going to be using the 93C56 because we're going to be communicating with a Motorola microcontroller. So what we need to do is we need to locate in the librarian or on the disk the entry in the librarian, which will give us that information. All right, well, how do we do that? Well, first of all, we have to navigate to where that is. All right, so to do that, I'm going to press P for path. The path command sets where I'm going to be working or what I'm going to be looking at. That's all it does. Okay, so I'm going to press P. And then I'll show you here, it says current path is EEPROM. Okay, that's a folder or a directory. Up here where it says new path, well, that just happens to be where the highlight is pointing. If I move the highlight around, this will change. Okay, if you wanted to point to a different place. Right now it's pointing at EEPROM, but EEPROM is not where I want to look. Okay, so what I'm going to do is I'm going to go over to EEPROM, and when I do that, if you look down here, it says subdirectories. Okay, well, subdirectories means there's a directory inside of a directory, meaning there are directories inside the EEPROM directory, or a folder in a folder. And the way that you get to subdirectories is you press the tab key. Okay, so I'm going to press the tab key, and that switches down to the subdirectories inside the directory. Okay, and you can see now that the current path is EEPROM, but the new path, which is where the highlight is pointing, is InfoDoc. Okay, information documentation. That's what InfoDoc stands for. So what we want to do is we want to open InfoDoc. Well, there's two ways to do it. I could press enter. That would basically assign EEPROM/InfoDoc to the path, or I can just hold down the Alt key and press L, which will take me as a shortcut to the librarian. So that's what I'm going to do. Okay, Alt L. Now, we're in the librarian of, or the library of info doc, which is in the EEPROM folder. Look up here. We always show you this is where you are. This is where you're working. Okay. These are the entries, the librarian entries. Okay, we have Bosch, these are Bosch cross-reference numbers. We have mask to part. This is the one we're interested in. We have mask info, which is an explanation of what the mask number is. Motor mask, which is another way to show it, and then part number. I don't remember what part number is. So anyway, we're going to go over to mask to part, okay, meaning the mask number to the actual part number. So once that is selected, if you look down here, we have how to use the mask number to part number selection list, okay? And then we tell you what to do. Press tab, change to view mode, which is what I'll do. I was going to do it. Press the tab key. And you'll see when I do that, over here we have a selector appear, which is a cursor. And then what we have below it, okay, I'm going to use the arrow keys. I'm just going to scroll on down. And these are all of the mask numbers and their corresponding part numbers. And if you remember, our mask number was E28B. Okay, so let's get on down to E28B, and I'll put the cursor selector right there on E28B, so you see it right there. Now, what's going to happen is I'm going to press the F6 key. The F6 key in the librarian will execute information on the line to which that cursor is pointing. In this case, we're going to select an industry standard part number. Okay. In the case of an airbag, it'll select and process templates. In the case of like a locksmith file, it'll select a part and load the appropriate reflash. The librarian is a very flexible feature of our software. Okay, but if you look over here on the right, it says 68HC11E9. Well, if you wanted to remember that number, then go back to the main command list, go to the device selection table, and manually enter it. You could do that. All right, but we don't make you do that. Okay, you've already found it here, so all we have to do is press F6, and when we do that, it'll come up and say device type updated, and it'll flip back to the list. Okay, so you're back at the top of the screen. But what happened is it actually picked a part for us. So how do we know? Let's exit out of the library, and we do that by pressing the escape key. And if you look, now that we're back at the main command list, device equals 68HC11E9. So you don't have to remember the mask number or the part number from the mask number. I mean, we do provide you a printed document which has a list of them on there. That's part of what comes with the ACOM 2, but you might as well let the system do the work for you. Okay, so now we are ready to proceed. So what I'm going to do next, I'm going to hook up the probes to the Motorola microcontroller, and then we're going to perform the reading of the source module, and then we're going to program the target. Okay, so I'm going to pause, hook up the probes, and then we will proceed. Okay, what I've got now, I'm going to show you. Let me switch to the overhead camera. This is the ACOM. I've already got it turned on, and I've got the probes attached to the Motorola processor. Let me pause this, and then I'll zoom in so you can see how the probes are attached. But I wanted you to see it. The ACOM 2 has got a switch here, and the reason we have a switch is because when I turn it off, the red LED indicating power supply to your assembly is out. So you want to hook up your probes. But you do not want to hook them up hot. So you hook them up, and then the connector for the probes goes onto the ACOM 2 assembly here with this little transition board. And then when you're ready to establish communication, you turn on the ACOM 2 like that. Okay, so now the ACOM 2 is on. We have power applied to the processor. We have the probes attached. Let me zoom in so you can see the probes. Okay, that's how the probes are attached to the pins. Basically, little teeny jaws come out the end of these probes. These are the standard surface mount probes that we provide with all of our kits. If you're dealing with a a smaller lead pitched part like you'd find in a, what's a good example? Sob twice module, well, that's pretty old. But anyway, the SO, or the quad flat pack QFP packages, the precision probe set that we sell is the same, but it's a lot more expensive and is an option. But anyway, here we have the 8 probes attached to the appropriate pins that were shown in the diagram. And now we're ready to communicate with the part. Okay, so let's do that. Let me go back to the main computer screen. And in order to establish communication, I'm going to select option Z. And if you look here on the screen, option Z says, or command Z is device options. Okay, any device that has options, such as communicating with a microcontroller, erasing flash memory, addressing the block protect bits in a 95 or 25 series SPI part, those are all things that you can access with device options, and that's how we allow you to perform those operations. So I'm going to press Z, okay, and it comes up with this screen, which says upload bootstrap program to device, which is option 1 right here, upload bootstrap program to device. Now what we're going to do, the way this works, when I press 1, we're going to load a communication program into the buffer. We're going to then upload that communication program into the microcontroller part itself. And it's going to start to run in the microcontroller. Okay, its purpose is to allow us to communicate with it. So we upload a communication program into the part, and it will allow us to both read and program the EEPROM. And once it's uploaded, you treat the part just like you would any other, external memory part. All of the same commands and functions are available. So I'm going to press 1 to upload the communication program, and look and see what happens down here. It will tell you what's happening. Okay, bootstrap upload in progress, buffer upload complete, communication verified. If you do not get communication verified, do not proceed, because if communication is not verified, you are not communicating with the part. And anything you do past that will not give you any kind of valid data. Okay, so now what have we done in the past? If you've watched our other videos, at this point we're going to go to the buffer editor, which is command 5. Okay, and it's initialized, it's all F's, which you've seen in the past as well. But we're now going to access the EEPROM in the Motorola microcontroller. So to do that, we're going to press G for get valid data, and it's accessing the part. And there is the data in the EEPROM of the Motorola microcontroller. Okay, now the device size, which is the number of bytes that occupies the EEPROM area, it's 0 to 1FF. Okay, so this is just 0 to F. This is one page. If I press page down, oops, let's clear that. Press page down. The second part of the EEPROM area doesn't have anything in it, so there was no data there. Okay, so let's go back up. So we now have that information in the buffer. Okay, so the next thing that we're going to do, okay, I'm going to do this, I'm going to show you 2 ways to do this. Alright, probably the easiest way for you to do it is we're going to save this to a file. And the reason we're going to save it to a file is because when we upload a communication program, we use the buffer to do that, and if we leave this information in the buffer, it's going to be overwritten or destroyed. Okay, so we need to save this to a file. Alright, so how do we do that? Well, we're going to go to, again, the path command, and let's see. Yeah, we can just save it in the info doc directory where we're pointing. So I'm not even gonna change the path command. Let's just go to command A. I'll do it from the main command list here. We're gonna use command A. Command A, if you look, save buffer to disk file. Okay, so that's what we want to do. We want to save the buffer, which has our EEPROM data from the Motorola microcontroller, to a disk file. Okay, so I'm going to press A. And if you look, it says current path. Okay, this is where we're pointing. EEPROM/infodoc. Okay, You can save it anywhere you want. You can use the path command to point to a different directory or folder, if you want to call it that. You can even save it directly to a flash drive, whatever you want to do. We're just going to leave it where it's pointing right now. And I'm going to call it, let's call it source, source.bin. Okay, bin is for binary. The reason that I append .bin, I suggest you begin to get into the habit of appending .bin is because bin stands for binary. And a lot of tools, if you don't have a binary extension on your file name, they won't even show it on the screen. Okay, so we're going to call it source.bin. Press enter. Save defined buffer range. Yes, no options. You can see it says defined range here is 0 to 1FF, which is all of the EEPROM in this particular Motorola microcontroller. All right, so we're going to say save. We're going to press Y for yes. File save complete. So we have now saved the file. Well, let's see. Is it really there? I'm going to press D right here. Directory of files. These are the files that are going to be in the directory that's pointed to by the path command. Directory, okay? And if you look right here, we have source.bin. Okay? Now, the next thing that we've saved our file. Alright, so now the next thing that we do is we get our target module and we're going to program the information from the source file that we just saved into the target module. Okay? So let me pause this and we'll get the target module installed, and you can see how that works. Okay, so what I've done, I've attached the probes to the target module. Let me switch over so you can see. Okay, I'll put a T on this module so it is represented as the target. Now, I'm going to go ahead and do what we did before, establish communication with the target. Press Z. Up. The COM2 adapter is not responding to port command. They're not responding because I didn't turn it on. So let's go over here and turn on the ACOM. Try this again. Z1. Okay, bootstrap upload complete. Communication verified. We are now communicating with the target module. So let's make sure we are reading data. So we'll go to 5. And I'm going to use this command you've seen me use in the past, which is the quick view command. Okay. So I'm going to press Q for quick view. And it'll say accessing part, and there is the data. So yes, we are hooked to the target module. Okay, now what we want to do is program the file from the source module into the target module. So we're going to exit the buffer editor. We're going to go back to the directory command where we have saved our file into, before we saved it into the EEPROM infodoc folder. And there's our file name right there. So what I'm going to do is highlight it, so you see how this works. Highlight it. And if you look down here, it says file name, F3 to program, F4 to load. Okay, so all I have to do to program this file into the Motorola part is press F3. And it will spring me to the program device from disk file procedure. And down here, well, first of all, it will tell you the number of devices required is 1, device starting address is 0, program or skip. Okay, the program or skip is there in the event that you're working with older equipment that had multiple EEPROMs and you wanted to skip some that were in a series, but we don't want to do that. So we're going to press P for program, and it's going to go ahead and program. It sees the bytes remaining down here, and when it's done, it'll verify. Programming complete, data verification is correct. Okay, so now we have cloned the information from our source module into our target module. Okay, well, I'm going to show you a trick you can do. It's a bit more involved than what we just did with the file, but I'll show it to you anyway just to show you what our product can do. Okay, program another set. No, we're done with that. But if I wanted to, I I have this file that's already in the buffer. So if I go to Command 5, there's the file. All right. And let's just do this. Let's clear this. Okay. Then I'm going to do Command G, and I'm going to read it because I'm already communicating with the part. I'm going to read it back into the buffer. Okay. But if I wanted to not save it to a file, what I can do is I can move this data, because if you look here, the device size is 0 to 1 FF. Okay, and so they've already programmed it into the target. I'm going to just use the target as it just stays as a way to show you how you could do this. Okay, I'm going to use the buffer. The buffer is going to be used to upload the communication program. Okay, but if I didn't want to save it to a file, what I can do is I can use a command called transfer in the buffer editor, which transfer, see down here, transfer device contents. And I want to transfer from 0 to 1FF, and I'm going to transfer it up to address 200. Okay, I'm going to press enter. And you didn't see it, it did it. All right, and I'll show you what I mean by that. Let's just do page down. Page down. If there's nothing in the second half of the EEPROM, but when I go to address 200, there's the same data. Okay. So now, if I were to reestablish communication with the part, the data, which is here, would be gone. So let's just do that. Okay. Let's just do that. Let's go back to the main command list, press Z, and 1. Okay. Now it just loaded the communication program into the buffer. Communication verified. Now if I go to the buffer editor, my data is gone. But is it? Okay, because I transferred a copy of it up to address 200, which is right there. Okay, so if I want to, and this is a bit more involved than programming from the disk file. The disk file might be more straightforward and easier for you to comprehend, but I wanted you to see some of the capabilities that our product has. So now I can say here, I can say program, enter buffer starting address, 200. Enter buffer ending address. Okay, well 1FF would be now 3FF. Okay. And I can say program or skip. So let's say program. And it's going to go ahead and program the copy of the data, which I transferred up, into the EEPROM. And voila, we're done. So if I go back, program note set no, command 5, let's press the home key to get back to the beginning and press command G to read it again. There's the data. Okay, so if you don't want to save it to a disk file, you can bring it into the buffer. You can move it up so the buffer, when the buffer is used to upload the communication program, it doesn't destroy your data which you read. Then you can program the data which you read from the area where you saved it above the top of the device and accomplish the same thing. I know you might not probably want to do that. It's something it's easier just to save it to a disk file and work with it like that. Anyway, that's how you do it. That's how you, in this case, clone a Motorola microcontroller from a vintage Mercedes E320 into a target. A defective one into a salvage one. So that pretty much wraps up this demonstration. As I always say, if you're interested in our products, we have a website and we have a phone number, and both of those are available at arlabs.com, which is right